In this video, I would like to explain the finding maximum subarray problem. First, please go to the canvas and go to the assignments. Go to the assignments, find the finding maximum subarray, right? And find this one. Click, find the sum subarray. Let me make it bigger. And the goal of this problem assignment is to practice divide and conquer method. So the problem statement is here. You click this here, this one, then you will see the open file like that. And also we give you the skeleton code. This is start code. You can download this one. For example, I click this one, right? Then we'll save this one. And you can open this one. You will find out we include multiple code. This is what we have. And we have integer maximum subarray generic tab. And we have a subarray generic subarray information generic tab. This one includes the main function. So if you want, you can open it in your the IDE tool. For me, I would like to explain what is finding maximum subarray sum problem. Okay, I would like to please open the file. You download from here, right? You download from here. And then you open it. The goal for this problem task is to practice divide and conquer technique, review the time complex analysis of recursion. Please develop a divide and conquer solution to determine a maximum sum of a certain sub-connection of one-dimensional array in the running time of O(n) log n. Please also perform a time complex analysis. Let's explain what is the story context in this study. So we see, okay, given a sequence of numbers, right? So the background story, let me make it a little bit bigger. Okay, that's good. So the background story corresponding to, for example, you are interested, you have some money, you want to invest your money in stock market. And with every day, the product in the stock market always increase or change, right? And you wanted to have different products. It could be like that. It could be like that, right? So, based on your money, you can only invest money in a product. You only want to buy one product. So it means you have to choose one to buy, right? So now the question this is even simpler than that. We say assume we give you the product, every day, what it is the price for this product. We want to decide when, so it means for each day, right? Day 1, day 2, day 3, day 4, 5, 6, so 30, right? For example, you want to decide when to buy it and when to sell it, to sell it, and such that the difference you earn, it is a maximum. You want to maximize. You want to maximize the profit, also corresponding to the price difference. corresponding to for example here, right? Corresponding to this difference. Between these days, it could be increase and it could be decrease, right? Decrease. But the idea here doesn't matter it is increase or decrease. The aggregated difference is maximized. This is the question for us. We want to find the starting point and end point and such that the difference between these 2 days has been maximized. Right? Can we sort this one? Can we base on the price to say, okay, we pick up a smaller one, we pick up the maximum one, then definitely there will be the good price, which may not be true. For example here, right? This is a smaller one, small price. Can you use this one? We say no, because we need to make sure the day you buy is before the day you sell, right? This is day. We need to make sure this is happening before that. And such that we're most interested it is from the aggregated price difference. This we care about. Then you may say, okay, how can we get the price difference for each 2 days? If we have n days, we say given n days, and price, let's move this one out. Give the price, give a sequence of prices, right? There's product prices, right? This is a stock product prices in n days to find maximum, let's say find the maximum, the price difference between two days, right? So this this is what we would like to do. Intuitively, let's say intuitively what we do, right? Intuitively, we say for any 2 days, calculate price difference, right? You buy from that day, sell from the second day, right? And such that if we have n points, we have n choose 2 pairwise days. And from these pairwise days, you find the price difference, and then you find the minimum one, and such that this is the n square runtime, right? Let's take this n square solution, n square runtime solution, and we want even better than that. We would like to find, so it means we need to find another solution. We need to find another solution. Which is satisfying O(n) log n, right? This we need to find. The question is, can we use divided conquer? Let's go back here. And here we give in this part, we give the formal description of this problem. Given array A of assigned integers, design algorithm that finds a subarray AI go to AI through J such that AI plus 1 plus AJ is maximum in term On log n. More specifically, find a pair I and J such that for any pair, the location pair I prime and J prime, and the sum of all the price from I through J, the aggregated price difference is greater than the odd and any other pi aggregated price difference. Here, we assume AI and AI plus 1 AJ, or each is number, we see if it is the price difference compared to the previous day. For example, if we give the price for each days, we reduce this problem, get the price difference compared to previous day, we got another array, is what we corresponding to A in this problem description. So in this case, it is our input for this solution, and it is a sequence of price differences daily, right? Daily. Corresponding to, for example, the 0 days, because you sell nothing, right? And the first day compared to previous day, the price increase 1, and the second day, the price drop negative 4, right? It drop 4, right? And the third day, the price increase 3. Each is number is compared to the previous number. The reason is we want to find the 2 days, and the aggregated price difference is maximized. We care about the price difference, right? Because it's corresponding to every previous day. High-level description, the intuitive method is to scan all the pairs AI and J and AJ, sum up all the elements from AI through AJ, and find the maximum sum. However, this solution takes the runtime of On squared. To obtain running time of On log n, we can apply divide and conquer method. Note the following properties of maximum subarray sum. First, if the array elements are all non-negative, then the maximum subarray is given by the sum from I equal to 1 to J through the n, right? If every day the price is increasing, in that case, of course, the first day the low price, the last day highest price, and we got the price difference. Of course, that is maximized. But it's just in the real life, the stock market, this data is not such nice. Second, if AI smaller than 0 for any I, then the maximum subarray sum problem can be defined as the element close to 0. Note that by definition, we disallow the empty connection as a valid input to maximum subsequence sum problem. In addition, note that the maximum subarray sum is not necessarily unique. There could be more than one subarray which achieves the maximum sum. Let's split the sequence in half, recursively solve the problem on both halves, and see what we can do. For example, imagine we split the sequence in the middle, we get the following answers. The maximum may appear from the left half, right half, or a consecutive subsequence across the element in the middle. Right? So it means first we divide into 2 halves, and maybe the best days we buy and sell from the left side, or maybe the best 2 days buy product or sell product came from the right side. But sometimes maybe you buy from the left side, you sell your product from the right side, across the middle, right? So for the last one, we can scan the left subsequence and the right subsequence in order to find a left start, which gives a maximum subsum in the left subsequence. ending in the middle element of the whole sequence. Find the right end, which gives a maximum sum in the right subsequence, starting from the middle elements of the whole sequence. The procedure can be recursively carried out till the base case only one element is left in each subsequence. Let me draw a cartoon picture here. Let's say we have a sequence, right? Sequence. So we cut into two halves, the left and right, and we first step, right? Find the split, right? Second step, we find the maximum subarray, find maximum subarray from left side, right? And third step, find maximum subarray from right side. Now the question it is, we have to find a subarray spanning the middle. And then fifth step, we return smaller one, right? So for example, let's say we call this one as, let's see how they call that. Okay, let's call this is the S, right? S sub, no, this is the maximum M, maximum subarray sum from the left side. This is MSSR side, and this is the MSS middle. And such that here we return the smallest one, minimum of MSSL, MSSR, MSSM, right? This we return that. So this algorithm includes these 5 steps. And for find a splitter, we can treat each side, we can use the middle point and the such that we can get 2 subarray of as equal size as possible, right? And then that will be easy. And use the same procedure for the left side and right side. That's recursive invocation, and find the maximum subarray that cross the middle point. And that is what we would like to emphasize. We want to check the time complexity for this finding the maximum subarray that cross the middle point. And this part is recursive invocation, same as what we drew here, right? And this is maximum spanning, and this is corresponding to the step. Let's see which step could be corresponding to. This corresponding to the step 4, right? So now let's take a look. This is the step 4. Let's take a look what they do in this step. This is corresponding to step 4. Find maximum span, right? Corresponding to find a subarray, which is a maximum subarray sum across sum, right? Is corresponding to find the maximum sum of subarray of a subarray crossing middle, right? Let's just simplify that. Okay. So if we draw a picture, then it will look like that, right? So we have the middle point, and which have different values, right? For example, let's say here is the day. Let's say this is the number 3, this is 4, this is 5, this is 6, and this is 2, this is 1, right? We have 0 here. And so we have value, this corresponding to the price difference. Let's say this is 3, it's -4, and this is 7, and here, let's say this is the this is the 8, and this is -2, right? And this is the plus, this is like +1, right? Okay, so if this is the middle, this is the middle, and this is, of course, is starting from 0, right? If this is the middle, in that case it is, and we want to check, we use this day as this is the price difference compared to the previous day. We want to check, we scan these elements from this side to the left side. We aggregated all the value for each another day. We want to see when they give you smallest value, right? For example, if you check from here, you got the 3. If you check here, you got, what do you get? You get a 6, right? And if you check here, the aggregated value is 6, right? And then if you can check for here, from this day you have 8, and if you go to here, you have 6. Then you have here, you have 7. In that case, you may say, okay, so definitely this day you want to sell, right? This day you want to sell, and which day you want to buy? Maybe this day you wanted to buy, right? So if we draw the picture, it corresponding to, for example, this is the price. Right? The first day is 1, and the second day it drop to the -1, right? And then third day increase even more, right? And drop and a little bit, right? In this case, you want to buy here and sell here, right? And such that you can earn the biggest price difference. So such that the running time, the procedure for the maximum span, it is you choose the middle and you scan use I as the count variable, scanning the odd and the price difference from the middle day to the lowest day. And every time you aggregate the specific price difference, you want to make sure you find the maximum value, maximum aggregated value. And in the right side, you follow do the same thing, right? And when you download the code, you may find out we provided the starting code. You can take a look. I'm not sure here, and let's see here. We only have separate place, the specific place we would like you to change, right? So for example, all the ones you see to do these comments, in that case, this statement is left for you to fill in. This is a find maximum subarray sum, and this one is corresponding to the subarray. This is the constructor. This is not a constructor. It's maximum span, right? This is have to do no comments. It means here is missing for you to do. This is exactly you follow this algorithm and trying to understand this problem. Then in that case, you can finish this task. So we would like you use these examples we give here. In this statement, we give 2 examples. We would like you test your code, by using these 2 examples. If you use Python, please also give us the snapshot of the execution results. I think that's all. Yeah. If you have question, let me know.